Assalamualaikum warahmatullahi wabarakatuh. This is Assignment Signal and System, SEM 1, 2021-2022. My name is FARAH NABIHAH RAMLAN. My group members is Nabilah AMIRAH binti AZHAR, NURBALQIS binti NAZRI, and NURBALQIS binti AZHAR. Introduction, we are given a task using MATLAB to visualize our original image into frequency domain using fast Fourier transform, which is an important image processing tool that used to decompose an image into its sine and cosine components. Next, we apply a blur effect in our image using Gaussian kernel blurring technique, which is a smooth blur resembling that of viewing the image through a translation screen. Distinctly different from the bokeh effect produced by an out-of-focus lens of the shadow of an object under usual illumination. After that, we detect the edge of our original image using deflection of Gaussian kernel, which deflection of an image highlights region of rapid intensity change and therefore often used for edge detection that see zero frozen edge detectors. The deflection is often applied to an image that has first been smoothed to something approximately a Gaussian smoothing filter in order to reduce its sensitivity to noise, and hence the two variants will be described together here.
Okay, I'm Bahira. So for the task one, we snap our photo of group members as our original image. We visualize original image into frequency domain using fast Fourier transform. Then we reconstruct the image to its real domain. Okay, first thing first, we need to create workspace, command history, and command window. So next, we assign our photo into in data. Then for the figure for the line 4, we show the image with title original image. So line 6, we convert the RGB image to gray. Then we display the image with title gray image. So for the line 9, we need to get Fourier transform of an image. So Fourier spectrum obtained by using function BS for absolute value. BS function to compute the magnitude square of real and imaginary part of elements the array. So line 13 is a Fourier transform of image. Then we display the image which is Fourier transform of image. So next, FFT shift to centerize the image. This is the coding. Then this is the line 18. We show the image to centerize Fourier transform of image. Then we apply the log transform. Then we display the figure 5, which is a log transform image. So lastly, we reconstruct image by inverse of FFT shift. Then we display the reconstruct image. So this is the output for figure 1. This is our original image. Next, this is our gray image. Next, for the figure 3, this is a Fourier transform of image. And for figure 4, we only got a dot at the center which is this is centralized Fourier transform of image. And for the fifth figure, we got log transform image. And the last one, figure 6, we reconstruct back the image. This is the output that we got.
My name is Nabilah Amirah, and I'm going to present for task 2. For task 2, we are going to use the isotropic Gaussian method, where it will increase the standard deviation. For isotropic, it means that it will have the same standard deviation for both dimension, which is on x and y axis. AMIRAH is a command that we use to import the image into the MATLAB. I'm Gaussian field is a command that we use to filter the image by changing the standard deviation or stigma to 2, 4, and 8. For figure 1, it will show the original image, this one. And for figure 2, it will show the smooth image with the sigma of 2. Like this one. And for figure 3, it will show the smooth image with the sigma of 4. The figure 4, it will show the smooth image with a sigma of 8. Next, just like previous, we will use the same command, I'm Gaussian filter, but the difference is we going to x and y value. For here, we are going to change the value of x-axis to 4 and to 8. But for this, we are going to change the value of y-axis to 4 and to 8. For figure 5, it will show the smooth image with the sigma x equal to 4 and sigma y equal to 1. This is the output. And the next figure, it will show the smooth image with the sigma x equal to 8 and sigma y equal to 1. For the next figure, figure 7, it will show the smooth image with the sigma x equal to y but equal to 1, but sigma y equal to 4. This is the output. And for the next figure, just like before, it will change the sigma x equal to 1 and sigma y equal to 8. Next, we are going to use I'm adjust command to specify the area inside the image. For this task, I'm using for sky image. For figure 9, it will show the original sky image like this. But for the next figure, just like before, it will show the filter image of sky. And this is the output.
My name is NURBALQIS and I'm going to explain for task 3, where we need to detect the edges using Laplacian of Gaussian and ask to observe the change in output image as we change the standard deviation. So this is the coding. First one, we display the original image, and then this is the coding where we put the standard deviation as 0.4, and then this is for 0.6 and 0.8 and then 1.0. So the output will be like this. This is for the original image. Standard deviation 0.4, standard deviation 0.6, standard deviation 0.8, and standard deviation 1.0. Okay, that's all. For conclusion, I will pass for the next member.
In conclusion, based on the given, we observe the output of the image when using the fast Fourier sum form, Gaussian kernel and adaptation of Gaussian kernel. In task 1, we get 6 figure of output image that we visualize our original image into frequency domain, and then we construct the image to its real domain. Next, in task 2, we observe the change in 10 figure of output image that we change the standard deviation value. The higher standard deviation, the more blur of the image. For example, when the sigma x higher, the smooth image will be blurred in x-axis, while when the sigma y higher, the smooth image will be blurred in y-axis. In task 3, we observe the change in the 4 different output images as we change the standard deviation value, which is when higher the standard deviation, the filter image will increase. That's all from us. Thank you.